Okay, Wildcats. Today we're going to journal page 55, graphing more complicated functions. Example 1. Enter the domain of the function using an inequality set notation and interval notation. For any x value excluded from the domain, select whether the function's graph has a vertical asymptote or a hole at the x value. Using a graphing calculator to check your answer. So we have f of x equals x plus 6 divided by x plus 3. Okay, step 1. Look at the denominator of the given function, and we're going to set that equal to 0. So x plus 3 equal to 0. And solve. So we're going to subtract 3 from both sides. So x equals negative 3. So we say the function is undefined at x equals negative 3. Complete the domain in each form. In inequality notation, we say x is less than negative 3 or x is greater than negative 3 because x equals negative 3 is excluded from the domain. Set notation, x such that x does not equal 3. Again, because it's undefined at x equals negative 3, so it's excluded. Interval notation, it's negative infinity to negative 3. The parentheses mean it's not included or not included negative 3 to infinity. Okay? All right, step 3. When a rational function has a factor in the denominator that is not also in the numerator, an infinite discontinuity occurs at the value of x, for which the factor equals 0. On the graph of the function, an infinite discontinuity appears as a vertical asymptote, so the graph has a vertical asymptote at x equals negative 3. All right, so let's look at the next example. All right, example 2. Enter the domain of the function using an inequality, set notation, and interval notation. For any x value excluded from the domain, select whether the function's graph has a vertical asymptote or a hole at the x value. Use a graphing calculator to check your answer. Okay, so we have f of x equals x squared plus 4x minus 5 divided by x squared minus 4x plus 3. So we're going to factor the denominator of the function while also setting it equal to 0. Okay, so we know 2 parentheses equals 0. We know to get x squared, it's x and x. Now we need to find out what numbers multiply to give you 3 and combine to be negative 4. Well, in order to get a positive number here by multiplying and combining, you get negative, that you have to multiply by 2 negative numbers. So negative 1 times negative 3 is positive 3. Negative 1 minus 3 is negative 4. So we have our 3 are negative 4, so our factors are x minus 1, x minus 3. Okay, we're going to set those equal to 0. So we have x minus 1 equal to 0, x minus 3 equal to 0. So we add 1 to both sides. So x equals 1. Add 3 to both sides. X equals 3. Okay, so the function is undefined at x equals 1 and x equals 3. Okay, step 2, complete the domain in each form. Inequality notation, x is less than 1 or x is greater than 1 or less than 3 or x is greater than 3. Basically, what this is saying is it's excluding 1 and 3. Okay, set notation, x such that x does not equal 1 and x does not equal 3 because, again, they're undefined at x equals 1 and 3. Interval notation says from negative infinity to 1, not including 1, or not including 1 to not including 3, or from not including 1 to infinity. Okay? All right, so go and complete step 2. All right, let's move on to step 3. Okay? Now, factor the numerator and denominator to find the whole. So, we know 2 parentheses. Okay? We know x and x. Now we ask ourselves, what multiplies to give you negative 5 combined to be 4? Okay, so since the middle number is positive, the bigger number is positive. So negative 1 times 5 is negative 5. Negative 1 plus 5 equals 4. Okay, so we have negative 5 and 4. So our factors are x minus 1, x plus 5. Okay, now we already factored the denominator. We know that it's x and x, make x squared, and we know that negative 1 times negative 3 gives us positive 3, and negative 1 and negative 3 combine to be negative 4. Okay? Now, to find the whole, you find out what divides and becomes 1. Well, this divides and becomes 1, so that's where your whole is. So we need to set x minus 1 equal to 0 and solve. So add 1 to both sides, x equals 1. So that is where your hole. Okay? Now, the remaining denominator you set equal to 0, so x minus 3 equal to 0. Add 3 to both sides. So x equals 3 is your vertical asymptote. Okay? So, let's look at that for a second. Okay, so the graph has a hole at x equals 1 and a vertical asymptote at x equals 3. Okay? Go ahead and finish up example 2. All right. Example 3. Divide the numerator by the denominator to write the function in the form f of x equals quotient plus remainder divided by the divisor. Okay? And determine the functions and behavior. Then enter the range using the inequality, set notation, and interval notation. Okay, so first we need to divide. Okay, so we divide x minus 2 divided into 2x plus 1. Okay, put a 1 here. Now you ask yourself, what do you multiply 1x by to give you 2x? The answer to that is 2. Okay, which is equal to the quotient. Okay, so now we need to find, we have the quotient, which is 2. So it's 2 plus, but now we need to find the remainder. So we need to finish the division. 2 times x is 2x. 2 times negative 2 is negative 4. But now you subtract. When you subtract a negative, it becomes positive. 2x minus 2x cancels. 1 plus 4 is 5, which is your remainder. Okay? So that's 2 plus the remainder, which is 5, divided by the divisor, which is here. The divisor is this right here. So 5 divided by x minus 2. Okay? Go ahead and finish up step 2. All right, step 3. Enter the range. In interquantitation, the range is y less than 2 or y greater than 2. In set notation, it's y such that y does not equal 2. And in interval notation, it's negative infinity to not including 2 or not including 2 to infinity. Okay? Go ahead and finish up step 3. All right? Example 4. Divide the numerator by the denominator to write the function in the form f of x equals quotient plus remainder divided by divisor. And determine the functions and behavior, then enter the range using an inequality, set notation, and interval notation. Okay? So f of x equals x divided by x minus 4 times x plus 5. Now to divide, we need to expand the denominator by 4. Okay, so x times x is x squared. X times 5 is plus 5x. Negative 4 times x is negative 4x. And then negative 4 times 5 is negative 20. Now, we simplify that. Well, that's x squared. 5x minus 4x is plus 1x. And then minus 20. So now we need to divide this into here. So we have, but the problem is we only have an x, but we have an x squared. So we have to add the 0x squared plus 1x. Now this has a constant, this doesn't, so plus 0. Okay? So now you're asking yourself, what do you multiply 1x squared by to give you 0x squared? The answer to that is 0. Okay? Which is the quotient. Okay? So that's 0 plus, now we need to find the remainder. So 0 times x squared is 0x squared. 0 times 1x is 0x. 0 times negative 20 is 0. Well, we subtract. Well, 0x squared and 0x squared, that's just 0. 1x minus 0x is 1x. And 0 minus 0 is plus 0. Which 1x plus 0 is our remainder. okay, which we can just write as x, okay, divided by the divisor, which is here, but we're going to use this form. This is the divisor right here. So x minus 4x plus 5. You wouldn't be mathematically wrong to use this here, but I know from the assignment they're going to use this. Okay? All right, go ahead and finish up step 2. All right. Now enter the range. In inequality notations, it's negative infinity is less than y and y is less than infinity. Set notation is y such that it's negative infinity less than y and y is less than infinity. And interval notation is from negative infinity to positive infinity. If I'm honest, these are the correct answers they're going to ask you to put for inequality set, but in this form, honestly, interval notation is the only one that makes logical sense. They all mean negative infinity, positive infinity, but they just write that. It's just a weird mathematical way to write that. It's correct, but weird. Okay, so we go ahead and finish step 3. All right. Example 5. Okay. Divide the numerator by the denominator to write the function in the form f of x equals quotient plus remainder divided by divisor. And determine the function's end behavior, then enter the range using inequality, set notation, and interval notation. So f of x equals x squared minus 5x plus 6 divided by x minus 1. Okay, so we're going to divide. Let's go ahead and put a 1 right here and a 1 right here. Now you ask yourself, what do you multiply 1x by to give you x squared? The answer to that is 1x. Now we need to multiply 1x times x is 1x squared. 1x times negative 1 is negative 1x. Now we subtract. When you subtract the negative, it becomes positive. Those cancel. Negative 5x and 1x is negative 4x. Now you ask yourself, what do you multiply 1x by to give you negative 4x? The answer to that's minus 4. Okay, now we multiply. And actually, don't forget to bring down the plus 6. So negative 4 times 1 is negative 4x. Negative 4 times a negative is a positive 4. And now we subtract. Okay, when you subtract a negative, that becomes positive. When you subtract here, that becomes minus. Those cancel. 6 minus 4 is 2. Okay, so this is the quotient. This is the remainder. And then this is the divisor. Okay, so the quotient is x minus 4 plus the remainder, which is 2, divided by x minus 1. Okay, go ahead and finish up step 2. All right, now let's look at step 3. Okay, enter the range. In inequality notation, the range is y less than negative 5.83 or y is greater than negative 0.17. In set notation, it's y such that y is less than negative 5.83 or y is greater than negative 0.17. And in interval notation, it's negative infinity to negative 5.83 or negative 0.17 to infinity. All right, if you would, go ahead and finish up your notes and have a wonderful Wildcat day.